Good morning to all from the editorial board of Build Up Portal. For the ones who are attending a Build Up webinar for the first time, welcome. For our returning audience, thank you for renovating your interest. Just a brief explanation of what is Build Up. Build Up is a collaborative platform in the field of energy efficiency in buildings. It is continuously updated and represents one of the key sources of information on the topic of energy efficiency. You can register and become a member of the community, and you can also upload news, events, present a case study, results from a project, and so on. I would like to invite you all to navigate the portal. In the Learn section, you will find all the podcasts of the past webinars, so it is possible to listen to all the previous presentations. At the end of this webinar, the link to the full presentation and the file to the PDF presentation will be made available in this section of the portal. It is a pleasure to host today's webinar entitled Deep Renovation Joint Webinar, which is organized in collaboration with P2Endure, ENVISION, and EENSULATE projects. I would like to invite you all to contribute and participate in this webinar. You can ask questions by typing in the box on the right side of the screen. They will be answered at the end, after the presentation. Now, I would like to leave the floor to Paola Robello from Arena Consulting, who will explain the agenda of the webinar, will introduce the panelists, and will give an introduction about the role of deep renovation to meet the European targets. So please, Paola, we can start the session.
Okay, thank you very much, and welcome everybody again to this webinar of today. The aim of this webinar is to raise awareness on the most innovative building renovation and energy saving solutions and to present technologies developed by 3 projects co-funded by the European Commission in the framework of Horizon 2020 Research and Innovation Program. This is the agenda for today. So after a short introduction of on the importance of building renovation to achieve EU targets, we will have 3 sessions dedicated to the 3 projects. First, we will learn about the P2Endure project presented by its scientific coordinator, Mr. Gianmarco Revel. Then we will have a session dedicated to the ENVISION project presented by its coordinator, Bart Eric. And finally, we will have a session dedicated to the EENSULATE project presented by Mrs. Daniela Riccardo as the project coordinator. At the end, there will be a question and answer session. So you are invited to ask to the panelists details or everything you want to know more about the projects. So a short introduction about the panelists of today. Well, that's me. My name is Paola Robello. I'm a civil and environmental engineer, and I work for the Research and Development Division of Arena Consulting. My role is mainly related to project technical coordination, and my field of expertise is mainly related to energy efficiency in buildings. Then we have the pleasure to have with us today Mr. Gianmarco Revel. He is full professor of mechanical and thermal measurements and sensors at Università Politecnica delle Marche, where he is also rector delegate for European research. He is responsible for 12 H2020 projects, and in particular, he is here today as scientific coordinator of the P2Endure project. Then, among the panelists, we have Bart Eric. He is a physicist. He works at TNO, and where he is responsible for responsive materials development for the built environment, with a special focus on coating research, transfer processes, and release of active ingredients in building materials. And he is the coordinator of the ENVISION project, among the other H2020 project he's coordinating. And last but not least, we have Mrs. Daniela Riccardo. She is a colleague of mine. She is part of the Research and Development Arena Consulting team. She is a civil engineer specialized in structural engineering and energy efficiency in buildings. She has a long and wide experience in the coordination of R&D projects, and she is the coordinator of EENSULATE. So going straight to the scope of today's workshop, it's a well-known fact that buildings are the single largest energy consumer in Europe. Specifically, according to the latest figures, buildings are responsible for approximately the 40% of EU energy consumption and the 36% of CO2 emissions. Moreover, the EU building stock is quite old, with more than a third of buildings being older than 50 years and 70% of them being energy inefficient. On top of this, the renovation rate is still quite low, accounting for the 1% per year. So in this framework, it's clear that the building sector is crucial for achieving the EU's energy and environmental goals, and in particular, the transition to climate neutral levels by 2050. To accelerate energy efficient investments in this area, the European Commission and the European Union in general has intensified its effort in recent years. Today, I would like to mention just two of the most recent legislative actions that has been undertaken and that are affecting the building sector, namely the Clean Energy for All Europeans package and the European Green Deal. The Clean Energy Package for All Europeans is a comprehensive set of legislations that defines European climate and energy policy for beyond 2020. And it also contributes to achieve the European Union's commitments under the 2015 Paris Agreement on the climate change. The package consists of 8 legislative acts being the result of an extensive revision and update of the already existing policy framework concerning energy efficiency. And as I said before, it is aimed at accelerating the energy transition in Europe. Among the many areas this package is affecting, strong importance have the building sector. In particular, the Energy Performance of Building Directive was amended, including specific provisions for the years to come. So the overall objective is to decarbonize the national building stock by 2050. And all new buildings must be nearly zero energy starting from the end of this year. At the same time, EU countries are required to set some requirements for the energy performance of buildings and to mobilize investments by drawing up a list of national financial measures to improve energy efficiency in buildings. And for the first time in this directive, health and well-being of building users is addressed, considering air quality, ventilation, and the use of smart technologies. In the framework of the package, some other directives were revised. For example, in the new version of the Renewable Energy Directive, a binding EU target is set of reaching 32% of use of renewable by 2030. And in the revised Energy Efficiency Directive, another target for 2030 is set of reducing energy consumption, reaching a 32.5% level. Moreover, with the new governance regulations, member states are required to draw up some long-term strategies and some plans in order to achieve the above-mentioned targets. The Green Deal, in a nutshell, is basically a roadmap which includes actions to boost the efficient use of resources by moving to a clean circular economy and to restore biodiversity and cut pollution. In the framework of the European Green Deal, it is foreseen to start a renovation wave initiative to be adopted in the third quarter of 2020, which main aim is to kickstart the transformation of today's buildings into the buildings of the future. And these renovation waves entails also a new way of thinking the energy efficiency renovation of building, a joined up thinking, because we all know that the building sector is characterized by fragmentation in the value chain. And so it's important to involve all the stakeholders that are important in the different phases of the building life cycle. The European Commission is supporting us in reaching these objectives, and real money are available to foster the transition to energy efficiency building. In particular, the Horizon 2020 Energy Efficiency Program provides support for innovation through research and demonstration of more energy efficiency technology and solutions, and market uptake measure to remove market and governance barrier, addressing financing, regulation, and improvement of skills and knowledge. Just to mention some numbers, an amount of 212 million euros were foreseen for energy efficiency calls in the last 2 years. Rina strongly promoted this webinar, and as a company, and in particular with our R&D division, we are strongly supporting through our research activities this shift towards low carbon energy and towards the integration of innovative renewable energy technologies in buildings. These aspects are considered as a prime mover in our evolution and the key to secure our success. We are very active in Horizon 2020, and in particular, we have more than 15 projects currently ongoing on energy efficiency in buildings. And as a company, we are very proud of being part of the consortia of the 3 projects that you are going to see today presented during this webinar. I give you just some insights on the project, and then I will leave the floor to the coordinators to better explain the innovative aspects. But we have P2Endure, which provide plug-and-play solutions for deep renovation of buildings. These solutions are intended to be easy to implement, faster to implement, affordable, scalable, and adaptable. In ENVISION, a full renovation concept is developed for harvesting energy from all building surfaces, both transparent and opaque, retaining at the same time the aesthetical aspects of the building. And finally, in EENSULATE, that we are coordinating as RINA, we're going to develop a new VAG technology for the envelope insulation of curtain wall buildings. So that's it from my side, and I thank you again for participating in this webinar.
Okay, good morning, everybody. This is Gianmarco Revel speaking from Università Politecnica delle Marche. Thanks, Paola, very much for the introduction. I'm going to present the project P2Endure. P2Endure is the first of the 3 projects that have been introduced in the previous speech. And it's about plug-and-play product and process innovation for energy-efficient building deep renovation. Basically, I will give an introduction, the context, the scenario from which we started. I will present the main objectives of the project, and which are the ambition mainly from the innovation point of view, case studies and prototypes. This is an innovation action with aiming at an high technology readiness level, and also some preliminary results. Of course, the project is not yet finished, so I will just show where we are now and what we are expecting by the end of the project, highlighting the future challenges and the lessons learned in this context. So the scenario where we move is a scenario that all of us know, and that is characterized by the drivers that pushed already since many years the Commission and the world community to aim at a greener and more sustainable construction built environment. So all of us know that we are aiming at the full decarbonization of the building stock by 2050, but this is not the only driver. In many cases, also the quality of the environments where we live is poor, is sometimes characterized by polluted air, 2-5 times more polluted than outside. And in many cases, still Europeans, the estimation, the statistics says 1 out of 10 Europeans cannot properly warm their homes in the winter, and 1 in 5 over 5 can properly cool in the summer. So there is quite a dramatic scenario that is still seeing a renovation rate which is very slow, 1-2 percentage per year, varying from different countries, but the average is definitely below 3%. In a situation where many technologies are available, including prefabricated solutions with good innovation already on board, the real problem is that still, both from the public demand and the private demand, the adoption rate of the so-called best technologies available is still very low. So this was the scenario where the P2Endure project has been conceived with the aim to promote evidence-based innovative solutions for deep renovation based on prefabricated plug-and-play system in combination with on-site robotic 3D printing and building information modeling, demonstrated and monitored originally on 9 real and 2 virtual projects in 4 geoclusters, so in an area with different geographical, cultural, and climate conditions with EU-wide replication potential. The consortium is led by Dimo, a high-tech SME from the Netherlands, which is the coordinator of the project, and our group at Università Politecnica delle Marche is scientifically coordinator of the project, which is a consortium of about 60 partners. Many of them, about half of them, are SMEs, because this is clearly a market with potential for SME business, which is a market, the prefabrication and the market for new technologies integrated in the built environment, which of course is expected to grow in the next years. The objectives of P2Endure is to reach, by using this PMP solution, by integrating optimally in an innovative process, this PMP solution is to achieve different main objectives: indoor environmental quality improvement, cost reduction with respect to state of the art by 15%, time reduction, which is in some cases important as well, by 50%, energy reduction in use by 60%, not only in use but also embodied energy reduction, so using green solutions with low embodied energy. Of course, fostering replicability of the business in Europe and abroad, and also keeping into account the disturbance of the building and construction processes on site, which is another element that quite often is neglected in the evaluation of the adoption of innovative solution. Basically, the P2Endure project is based on the so-called 4M process, which is here briefly represented. It's basically not really something new, I would say, but it has been for us a driver to guide the development in a systematic way, which is in some case very important to bring scientific results into real product exploitation. So the 4M processes see a sequence which goes from mapping, so understanding, evaluating, assessing the performance and the condition before the renovation. We are talking about deep renovation. So deep renovation means when everything has to be mostly reconstructed, so not just partial retrofitting. Then modeling, and based on the modeling, performing the renovation design. Then off-site manufacturing and on-site assemblies of the PMP solutions. So this is the making. And finally, monitoring the performance and the condition after deep renovation using innovative technologies. So, and this can be, of course, a circular approach where we try to bring some innovation in each of the 4M phases. And I'm going just to show briefly which are the main innovation that we try to introduce, to develop and introduce. Concerning the mapping, basically we try to feed all the information achieved from condition assessment in an as-is built BIM model, using first of all 3D scan, but also using some innovative technologies like a technology that we developed and patented at Università Politecnica delle Marche, which is the Comfort Eye. The Comfort Eye is this device that you see here where I'm clicking with the mouse, which is a device which allows very quickly to monitor different comfort quantities and comfort spatial distribution inside environments, allowing to identify main leakages and main problems in a three-dimensional environment. This coupled with other technologies like infrared thermography, like 3D rendering, is one of the several elements that have been integrated to innovate from the mapping point of view. Then once that the as-is built model, BIM model, is available, we have been working on the modeling phase, in particular focusing on making a kind of smart and automatic the BIM-to-BAM process, which is quite a challenging step, not always easily implementable, but we coupled this with parametric modeler, and this allowed to, in particular for some of the demo cases, to speed up the process to make BEM. When we talk about BEM, of course, we mean building energy model. So passing from the BIM to the energy simulation in a parametric and not too much time consuming way. So the mapping, of course, the modeling, of course, is a very important step where we therefore try to also define some key performance indicators and some benchmarks for the baseline. And here I report some steps that can summarize some of the mapping modeling processes that have been implemented. So creation of the baseline, validation of the baseline with energy bills, creation of the post-renovation model, so simulate the post-renovation model, evaluation of the performance of the renovation, and basically try to fine-tune the solution proposed and implemented so as to achieve the target 60% percentage energy saving, which is the target to be achieved. The last step of the process, the third step of the process is the making, manufacturing and assembly of PMP solution. Here as well, some innovation both on the processes for off-site production and also for the robotics, like 3D printing or robotics for installation have been adopted. Actually, many of those were already at the prototype level available before the project. So what we really aimed to was to integrate all these components into a solid process, which can be referred to this 4M approach. And the last step, of course, is to make post renovation monitoring. And this is fundamental, as we know, to make a comparison with the pre-renovation situation, and also to guarantee high quality execution. And a particular emphasis has been put also to matching the energy targets and the cost targets whilst saving the indoor environmental quality. We all know that in last years, a lot of work has been done by really increasing the thermal insulation, and now the focus is going more and more in the direction of preserving, in any case, the indoor environmental quality. And here we just have some pictures of some of the innovative devices that have been developed and implemented concerning the monitoring not only of the thermal comfort but also of the air quality. and lighting quality, so visual quality as well. So we try to target a multidimensional comfort approach, which has to be validated after the renovation process. This is just an example of some of the results from the raw results, which of course then are post-processed from the comfort eye, which maps the radiating temperatures in the environment with a resolution which preserve in any case the privacy of the user, but enough to allow understanding the real comfort distribution inside the environment and eventual fine-tuning of the renovation process that needs to be performed. Of course, this is, as I said, a circular approach, because then the circularity of the foreign process can restart in such a way as to guarantee to reach the final achieve the final targets. Several prototype and innovation that, of course, I have no time to go into details right now, have been integrated, ranging from smart windows, smart plug-and-play facade elements, bath units. There are several of them that have been integrated, that you can find, for which you can find information also on the P2Endure websites. One important part of the project, being an innovation action, is of course the demonstration. So we tried to make demonstration, as I said, in different geoclusters and also in different kind of buildings, and both real demonstrators and also in some cases where it was not possible to perform the desired work before of local situation. We implemented contingency plans with virtual demonstrators. So we have several demonstrators around Europe, and the Netherlands, Germany, Denmark, Poland, and Italy. And actually, at this time, we have implemented most of the demonstrators, and right now these are some of the results that we already achieved in the different demonstrators for the different objectives that we tried to explain and present at the beginning of this presentation. As you can see, in many cases, for example, the energy aim reduction is already achieved. Not always. Many of the results are still under evaluation, are in progress, but it looks like the results that we are achieving at this time are quite promising. So here you see on the lines the different pilot locations, and in the columns you see the different objectives. So the primary energy, embodied energy, renovation cost, renovation time, replicability and scalability, disturbance, and indoor environmental quality for the results that we have achieved until now. Some of them are still under computation, and in some pilots the monitoring is right now being completed. A last important part of the project has been to foster also the market implementation of the best available technologies. Basically, P2Endure is making incremental innovation in the single item, but an important part of the innovation is the integration of all of them into a unique approach, and they are the business model that is promoting the approach. So a new marketplace is at the base of the approach that I just showed from the scientific and technological point of view. I will try very briefly to show, using this diagram, how this can be implemented. And this, of course, starts from here, from the as-is beam model. Then from the as-is beam model, we have the BIM model of the current situation, where from the e-marketplace several solutions that are available on the product on the market with the product data can be included, and this allows to make to have data for energy calculation before and after, using the parametric product data that are available on the e-marketplace. And this, of course, requires several steps like the BIM to BAM process, which are not straightforward, that we are trying to integrate into a unique approach, which we believe to be very relevant to increase exploitability and replicability of the solutions, trying to involve all the main actors of the business model, which basically are to be involved in a local district renovation platform. So basically, there are different stakeholders that should contribute to this process. The local government, which make the regulation and can be also give some incentives, the owners, the inhabitants, that has to be proactive, also to qualify the demand from the private side. And finally, of course, the industry and the SMEs of the sector, which should be capable of bringing innovation in the market and to give the answer to the owners according to the local regulations and local available technologies. So the e-marketplace and the business model in the project is meant to satisfy all these items. Of course, there are lessons learned and future challenges. This is my last slide. So we understood that still, of course, this is a slow process, mostly due to the slow adoption of innovation in the sector, but probably local district alliances may help to overcome the situation. Many cases there is lack of knowledge, so that's why we believe a knowledge sharing platform can increase the awareness. Low involvement of end user in retrofit process is another point, for example, which in the future can be helped from the use of gamification techniques. And finally, we really need to move for the deep renovation where heavy works are required to mass production. And so more and more we are trying to push the use of robotization and automatization in prefabrication. So this gives out also a final view on future challenges for the application of PMP solution in the deep renovation process. Okay, that's all from my side. I'm available, of course, later for any questions. Thank you very much.
Good morning, everybody. I'm happy to present the ENVISION project. My name is Bart Erich. I'm coordinating this European project. And as any European project, each project has an acronym, in our case called ENVISION, which is meaning energy harvested by invisible solar integration in building skins. And that's what I'm going to talk about. And I think it's best explained by example. And here you see a building which was recently finished in November of last year with one of the technologies which is currently in the ENVISION project. And what you see here is a sports hall of in a municipality in the Netherlands. Sorry, I did not share my screen yet. Anyway, let's continue for a moment. And this building was recently opened, and people were seeing this building, and we asked them, what do you think about this building? And we told them that we have energy harvesting inside this building, inside the facade. And then people were coming to this building and have a look at the new technology, and they were actually asking, where can we see the energy harvesting panels? And this triggered us because it actually indicates two things in public's minds, that people think that energy harvesting solutions should be clearly visible, which we know from photovoltaics in roofs. And it also said that we were quite well achieving energy harvesting in this building. So what you actually see here is the panels, which are the green panels on the roof. And these panels are coupled to a heat pump and generating heat for this building. And what happens is that the building is used as a sports hall for a primary school in the municipality of Almere in the Netherlands. And to heat the sports hall, this heat pump is used connected to these panels, and also it also generates the hot tap water to allow the children to shower after their sports events. So this is exactly what we want to achieve. We want to use as much surface of building for energy harvesting without being visible. So back to the ENVISION project. This is actually exactly what we're aiming and demonstrating, to go to an integrated renovation concept where we use all the available building surfaces for thermal and electrical energy harvesting. In total, we have about 13 partners. Our project is 45 months and ends in 2022. In March, we have about 6 million budget, and work is distributed in 8 work packages. And so, trying to go to the next slide. What we wish to do is achieve the European goal of energy neutral built environment in 2050, and use all the surfaces of a building to harvest solar energy. And as was explained before, the challenge is quite big, because if you look by 2050, that means that 85% of the current existing dwellings are already there. So in 2015, only 15% will be new buildings. And a lot of these buildings were with poor insulation. That means that in the upcoming years, major renovation will take place. And that means that our solutions should be easily be integrated in buildings. And you know already that a lot of roof areas nowadays are equipped with photovoltaics to provide electricity. And if you use the total surface areas of these buildings, still we can't solve our energy demand. About 2/3 of the energy used in the built environment is also for heating buildings. So if we have this electricity, we have a lot of issues related to the grid, storage, etc. So that's one of the reasons why the ENVISION project focus on heat harvesting solutions, and using the 60 billion square meters of facade surfaces next to the 60 billion square meters of roof surfaces, which is available throughout the European Union. So in total, that would mean that we have 120 billion square meters of potential of energy harvesting surfaces. So now let's have a look at what is the basic principle. So the basic principle is grab what you can without noticing. So that means we want to get as much energy as possible without any aesthetic effects. And this is a big challenge. And now there's another fact, the fact that the human is quite blind. So if you look at the solar spectrum, which is shown in this graph, you see on the x-axis the wavelength and on the y-axis the power produced by the sun. And we see that this near infrared is actually not visible by eye, but it's still 50% of what we can see, what is emitted by the solar radiation. Okay, so if we can use this near infrared, we can make harvesting technologies which are invisible. So the key objectives of the ENVISION project is active harvesting, but our solution should be easily to be maintained, and to get maximum efficiency, we would like to link the heat generating facade to a district heating network, so that the energy which is produced can be fed into this district heating network, so that it can be used or even stored in some cases. And if we want to do that, we want to have solutions which can be easily installed, has a large scale deployment potential, and should be cost effective with a return of investment with less than, preferably less than 10 years. There's a short project video which is available on the website on ENVISION. Unfortunately, today I cannot show it, so I will move to the different technologies which we are actually testing. And here you see two heat harvesting technologies. On the top left, you see the heat panels, which are colored, 3 panels are colored green, a yellow one and a red, in which we together with AkzoNobel, the paint company, we developed coatings which harvest this near infrared. So we can even make white paints which harvest 40% of the sun, which is very exceptional, because normally 89% of the heat is reflected. So you only have an absorption of about 2%. So this shows the test setup at the Solar Application Center of TNO, the Netherlands. I will get back to that. On the same roof, we developed together with NSG Pilkington, the glass manufacturer, a coating on glass which has a color. And you see that on the right picture here. You see a red panel, a black and a blue panel. And these panels have harvesting sheets behind it with tubes which harvest the energy. So we can produce different colored glass, and behind this glass we can harvest the energy with some metal sheets and piping. The same is done for these panels, where the energy is also harvested with some tubing. These are solutions which can be used in opaque surfaces, but we also said that if we want to use all the building surface, we should also look at transparent parts of the building and see what we can do there. And one of the technologies we are investigating is a smart ventilated window, where we have a glass sheet which harvests also the near infrared. So the sunlight goes through this glass sheet, and then it heats up one of the inner panes of this glass. The visible light is transmitted inside your building, so you still have light inside your building. And when this inner glass sheet is heating up, this air is fed into the room or is harvested into via a heat exchanger into water, so which you can use for heating or creating tap water using a heat pump. And this is a completely new concept, allowing a lot of energy to be harvested. Another somewhat more conventional technology is photovoltaics. But photovoltaics is normally used on opaque surfaces, such as the roof. But in this case, Energy Pilkington has devised PV harvesting glass, which has PV stripes on the glass. And especially this type of glass can be used in stairwells of apartment buildings, where you have you can view the outside and still have energy harvesting. And in this case, the surface area is about 50% covered. And this is a beautiful technology which you can use in parts of a building where you need light and have a possibility to look outside and use that surface at the same time for energy harvesting. So these are the core four technologies which we are developing and showing and testing in the ENVISION project. And our testing strategy is as follows. So all the technologies will be first tested in a kind of mock-up demo sites, and we use two main testing facilities. One is the solar beat of the Solar Energy Application Center of TNO in the Netherlands. It's housed at the Eindhoven University of Technology of the and on a roof of the Built Environment faculty of the university. It's a cooperation between TNO and the university, and where we test all kinds of PV and thermal solutions. And in our case, both the uncovered and covered collectors are tested, as well as the PV glass of Pilkington. And the smart ventilated window is tested at the best lab of EDF in France. So all these intermediate testing before the products are being placed in a real demo site allows to improve in several steps the products. In the next step, we move to two demonstration sites. One is located in Italy at the University of Genoa on the Savona campus, where the technologies of the ventilated window and the solar collectors are coupled to the local smart grid, where the harvested energy is used for heating up the buildings on the campus. And the University of Genoa is currently investigating how these technologies can be coupled and fed into different generations of heat networks. And in the next step, we also wish to really demonstrate this in an apartment building. And currently, this is being worked out, and we hope to start the building in the beginning of next year, where we really integrate these panels into the apartment building to see if we can use both the roof and the facade for energy harvesting, which is crucial for apartment buildings because there's relatively little surface which you can use for harvesting and a lot of energy use because a lot of people are close together in this building. So then finally, I would like to end showing you some future pictures to envision our future. So this will probably be one of the future visions. We will look at buildings which have nicely installed aesthetic panels where heat is harvested without seeing it. Here you see the sports hall in Almere. This is an impression of an apartment building where the end facades and the front facade, some panels are integrated here, the red ones and the gray ones here on the sides, together with the PV on the roof, will ensure a near zero energy building. And even more impressions. Here is an impression made for also for the municipality of Almere where different panels are integrated in the building with PV solutions on the roof. And I would like to kindly thank all the partners in our ENVISION project, such as BAM. BAM is a large building contractor, Energy Pilkington, RINA, Emergo, which is a prefab element producer, EDF, University of Genoa, Vestia Social Housing Corporation, Axo Nobel for developing the panes and the ventilated windows by BG Tech. I would like to thank you for your kind attention, and if there's any questions, I will be available during this webinar. Thank you very much.
Good morning. My name is Daniela Riccardo. I would like to, first of all, to thank BuildUp for hosting our webinar and all of you for joining us. I am the project coordinator of EENSULATE project, as anticipated by my colleague Paola. And now I would like to present to you the main achievement of our project. EENSULATE project started in August 2016, and the official end date is fixed by the end of this August. Unfortunately, due to the coronavirus emergency, the consortium is considering the possibility of asking for an extension to the European Commission in order to finalize all the project activities, with particular reference to the installation of the results in the pilots. The target of the project and of the things that we are developing is existing building as well as new construction. The project has an overall budget of 6.6 million and is developing 3 key enabling technologies, in particular the sealant, the getter, and the foam. The consortium is composed by 13 partners from around Europe. And this is the general overview of the consortium of EENSULATE project. The main challenge, as well as the target of our project, is the curtain wall system, because thousands of buildings in Europe have been constructed using this particular technology. And many of these buildings are now old, let's say around 30 to 50 years old, or even more. In addition, curtain wall technology is recently used not only in office buildings, but also in residential applications, such as the construction of residential towers within the urban context. In this particular context, the noise pollution is a key aspect to be considered. Furthermore, windows and glass facades are estimated to be responsible for up to 60% of energy losses through the envelope. Therefore, the replacement and retrofitting of existing curtain walls would allow a significant enhancement in the thermal performances. And in addition, it would help in minimizing the discomfort to the occupants. The curtain wall modules developed within EENSULATE project is composed by the novel EENSULATE glass based on VIG technology and the EENSULATE foam in the spandrel, combined with low E coated glass, including thermochromic coated glass with additional self-cleaning and anti-fogging functionalities in order to achieve all the thermal and mechanical performances in agreement with the technical and standard requirements, taking into particular consideration also the market drivers. The main technologies at the basis of the products developed within EENSULATE project are the vacuum insulated glass with innovative sealant and getter technologies, and the highly insulated foams based on monocomponent and bicomponent elements. The vacuum insulated glass is realized by Bigitech with a tailored and fine-tuned manufacturing process, implementing the innovative sealant and getter strips to ensure the target performances. Up to now, Bigitech realized already small-scale VAG prototypes, 500 per 500 millimeters, and these kind of prototypes have been tested, and the results are quite interesting because they achieved a new value in the center of the prototypes of 0.36 watt per square meter Kelvin and 0.44 watt per square meter Kelvin as an overall U value. In addition, Bigitech already realized some large-scale VAG prototypes for additional testing in a real environment of 1000 per 1000 millimeters. And the final scope is to produce real scale VAG for pilot application with dimension up to 2000 per 800 millimeters. Concerning the foam, this particular type of foam is developed by Selena, and it is an highly insulating monocomponent foam, or CF, for Windows application, and a two-component foam with high fire class for spandrel application in the EENSULATE module. This innovative foam is a foam with a tailored cell morphology, size, and structure in order to enhance thermal performances through the precise control of the cell's nucleation events, which generate the foam itself. Regarding the sealant, it is produced by SAES, and it is the innovative sealant is an epoxy resin-based sealant in strips for the application in the vacuum insulated glass. The thermal curing is allowed at, already at a low temperature, below 200 degrees, and this is a challenging innovation with respect to the sealants already available on the market. In addition, SAES is developing, is working on the possibility of having the monocomponent sealant resin in a syringe dispensable, so that it is dispensable directly by the who will assemble the VAG system in a range of 60 up to as maximum 100 degrees. A key aspect of this sealant is the permeability, because this sealant it represents an extremely high barrier for argon, nitrogen, and oxygen. In addition, it is also an active filler for moisture absorption. Concerning the use of this sealant, regarding the process, it is mainly done in air with an easy handling. But concerning the storing, it is necessary to stock it in a freezer at a temperature below minus 20 degrees for preserving its properties. The getter is again developed by SAES, and it is a distributed getter realized with innovative zirconium-based alloy with extremely high nitrogen capacity. The getter is composed by laminated double-side getter strips with a size of 200 micrometers thick and 8 millimeters large. This particular size of the getter enables the utilization in the VAG technology because of the limited thickness. It is again easy handling and it is positioned in air during the production process of the VAG. The getter activation process is performed by radio frequency heating under vacuum pumping. In Insulate, we have 3 different demonstration buildings located in the different climatic areas of Europe. 2 of them are placed in Poland and 1 in the south of Italy. The first demo building is a school, a Polish school located in Georgianów, and the intervention consists in the installation of the renovation of the facade system by installing the Insulate module. In this particular case, we will install in the Insulate innovative module both the VAG developed within Insulate project, that is the innovative solution, and some modules with triple glaze units directly from available on the market. This approach will ensure the possibility of comparing the measurements that will be performed during the monitoring phase in order to assess the actual performances of our system with respect to the system that are already available on the market. The second demo building is the museum, located again in Georgianów in Poland. This is a very particular application because it is an old building. It is representing an historic and artistic heritage. Due to this, the fact that it is a valuable building with the restriction in terms of intervention that can be performed, the type of intervention foreseen in this building is the renovation of some windows. In particular, the intervention consists in simply renovate the original sash and install in the original sash the VAG developed by Insulate project. And finally, we have the last demonstration building. It is located in the south of Italy, in Pesaro, and it is the San Giovanni Public Library. In this case, the type of intervention is a door window that you can see the photos in the bottom right part of this slide. And considering the fact that in this case the door window is quite new, we simply again install the VAG in the already existing frame. All the 3 demonstration buildings will be monitored, and the results will be analyzed in order to validate the results of Insulate project and its product. Finally, I would like to give you a general overview of the main impacts of our project. We can say that we expect the 15% of reduction of energy spent during the whole life cycle of a building, and the 20% of improvement in terms of durability. We can say that the expected lifetime of the VAG is 20 years. In addition, a 25% of improvement of insulation properties because of these particular technologies of VIG, and 10% of enhanced water vapor permeability properties. Finally, last but not least, a reduction of the total cost of the 20%. That's all from my side. For further information, you can contact direct me or ask a question immediately after this speech. Thank you for your kind attention.
And thank you all for your presentation. So we can start the Q&A. Let's start with the first question, which I think is for Gianmarco Revel. Specifically, what kind of pre and post in situ building performance monitoring do you conduct, and for how long? This can be challenging for bigger scale projects. Do you measure CO2, temperature, RH? How do you measure energy consumption?
Yes, thank you for this question. Of course, this is a very important point. We have been trying to develop a kind of kit, a kind of integrated solution which can be used for pre-monitoring and monitoring pre-intervention and monitoring post-intervention with the same modalities in such a way as to have comparable results. Further than pre-intervention, of course, we monitor. Further than, of course, we check the energy bills. Let's consider that this is a deep renovation project, so means that almost the whole building has to be reconstructed. So basically, we try to monitor further than the energy consumptions. That we pre-intervention we base just on mainly on the bills, and in some cases, if we have some doubt about the energy consumption, we make some more detailed measurements on some energy consumption items. But most of the attention has been focused on the indoor environmental quality. So basically, we measure quantitatively comfort, which means not only temperature, but radiant temperatures, humidity, air flow velocity, air velocity, and all the other quantities that normally, air temperature, of course, that normally are influencing the comfort sensation. Then we monitor the air quality, CO2, and also ppm, PM10 and PM2, and the main PM components, VOCs in some cases, and also lighting conditions. So indoor environmental quality is fully monitored pre and post. And in some cases, there are also some surveys that are done to the occupants to support the quantitative measures that we do. An effort has been done to make some of the measurements, like the comfort measurements, to make them objective and not subjective. This is very important because if you want to move ideally from energy performance contract to comfort performance contract, which means that you make a renovation process and you guarantee not only some energy targets, but also some comfort targets, then you have to make a quantitative certified measurements.
Thank you for your answer. Let's go on. Is the P2 Endure program applicable for all kinds of buildings? Did you develop different methodologies based on the construction type? For example, for historic buildings before the 20th century, which require more detailed study?
Well, very good questions. I have to say, P2Endure has to be seen like a catalog of integrable solutions. So we have several products, several PMP solutions that can be chosen. I try to describe this a little bit from the marketplace approach. Can be chosen to make the specific work which is intended for the deep renovation. So based on that, there are some of these which might be interesting also for example, for cultural heritage buildings, which is like, for example, the 3D printing, which can really replicate some of the original building details or building shapes. Of course, so several of the solutions are applicable for different kind of buildings, and indeed, within the demo cases, we have different kind of buildings, ranging from social housing to schools, nurseries, residential, so different kind of buildings in different areas. But not all the solutions are applied for all the buildings, for all the demo cases, sorry. So this means that, of course, for some buildings, some solutions are more applicable, and for other typologies, other solutions are more applicable. And this, of course, is evaluated in the modeling phase, where the model of the renovated solution is implemented.
I got another question regarding this project. Are there any open source tools developed by and for the P2Endure program that could be used for current retrofit projects? We are working on different big-scale energy retrofit projects in Scotland and would be very interested in applying the P2Endure procedure.
Well, of course, it's not yet open access. It's a platform which will be available after the end of the project. The project is not yet concluded. It should conclude after the summer this year, but there might be some delay due to the validation in some of the buildings, of course, due to the pandemic situation. These buildings where we are making post intervention monitoring are not used, so of course the monitoring is not fully completed. But in any case, for any specific information about that and the follow-up, just send me an email, and I can give more information.
So regarding the EENSULATE projects, are there other possibilities than petroleum-based foam?
Yeah, originally Selena, who is the partner responsible for the development of the foam, investigated different kinds of foam bio-based. But finally, according to the results of the preliminary tests, they decided to focus on the ones presented.
Okay, thank you. So we got another question actually for P2Endure. Do you see this project viable for one-off domestic deep retrofits, or more for replication on housing estates and apartment blocks?
Sorry, more for replication?
Or more for replication on housing estates and apartment blocks?
Okay, well, actually, I think both of them. As I tried to explain, it's different scalable and modular solutions. So I think that some subsets of the whole solutions can be easily applicable to both the cases. So we tried to, as I said before, to investigate different pilot cases, really to try to see which are the strong points and the weak points for the different cases. And this will be, of course, one of the lessons learned from the project.
Another question, which is the technology readiness level of all these proposed technologies at the end of the project, and how far is the full commercialization phase? I'm thinking about the fact that the new and even more attractive incentives are going to be enabled at member state levels. Then it is important to keep the opportunity right now.
It's always to me for Peter and Dur.
I think it's for everyone who would like to answer.
Yeah, okay, so well, I quickly start. That's a very interesting question. For example, in Italy, it looks like we're gonna have this kind of super bonus, which will fund 110% of out of 100 expenses. Yes, well, actually, the TRL of these solutions, most of the solutions is quite high. I would say, if I have to give a number, we are already, I would say, some around 8, 7, 8, and they are already installed and demonstrated and working. I think so. It's true that that's a very good moment to try to kick off with the real projects, trying to get the incentives. I think that a little bit more time will require the full integration of the whole process from the platform point of view. This is still, of course, is maybe at a slightly lower TRL. There are some steps like the beam to BAM, which are not always easily madeable, doable by automatic procedures, and this, of course, may require some longer times. Right now, we are drafting the exploitation plan for the project, trying to highlight some clear exploitation routes. For example, some of them will be for the monitoring pre and post renovation phases. Probably we will supply these not only with the devices that are already at the TRL enough to be commercialized, but also as a service, making already pre and post monitoring and offering solutions for retrofitting.
If I may add something regarding EENSULATE products, yes, we are more or less in the same TRL level. The results and the products of the project is quite high, even if they are not ready right now to be for the market. We are working in fine-tuning some solutions, especially regarding the manufacturing process, because, as I said, the manufacturing process of most of the products is now mainly manual, and the industrialization would be the step forward to enable the introduction of the products into the market.
Maybe I can comment for the ENVISION product. In case of ENVISION, we have 4 technologies, and the PV glass is going to be manufactured by NSG Pilkington. So I think through Energy Pilkington, this glass can be ordered. The current situations, however, that's done mainly manually, so that means a lot of work has to be done, and to get the price down, a lot of automation has to be done, which is the same for most of the other products within ENVISION. At the moment, the uncovered panels, we are busy with setting up a joint venture together with the partners to be able to manufacture the panels so that we can largely produce these panels for a lot of projects. For the ventilated window, however, I think still a lot of steps are to be taken to work it till a commercial product. For the covered glass, we are still investigating the possibilities there, but mainly there's the production is the main key issue.
Thank you. So there is another question for all the three projects. Did you consider the end of life of the different products developed during the project?
Maybe I'll react first. For the ENVISION project, we have looked to what the products are made of. So for us, the key two aspects were durability and guarantee and quality, and we also investigated what it would mean at the end of the lifespan. In our case, the panels are mainly aluminum or other metals, so the metals can be reused. And for the glass in general can also be reused, so that's quite efficient. So that's very positive. For the ventilated window, it's almost like a normal product, so there's not a big step here. And if you have a normal glass, you can just reuse it, so that's quite positive.
Well, concerning P2Endure, of course, as I said, there are several different solutions. So the durability has been, of course, evaluated, and it's currently under evaluation as well. What we try to do is, of course, a whole life cycle evaluation approach, not only concerning the duration, but also concerning the LCA impact. And this for the more material-based solutions, and some of them, on the contrary, are more IT-based solutions, for which, of course, the duration is related to the reliability of the implemented solutions. We believe this to be quite positive. Of course, as I said, it's a kind of 10, 15 different solutions, so it's difficult to give numbers right now.
Okay, concerning EENSULATE project, as I said during the presentation, the durability, in terms of durability, we expect to have a durability of 20 years for the VIG panels. Of course, the tests are still under performing, so we do not know exactly right now which are the results that we will achieve. The same concerning the end of life. We are currently in this month performing the life cycle analysis of all the products developed and the solution proposed. And we expect to have the final results by the end of the project. If I have to give you a general overview, I can say to you that it depends on the materials which are at the basis of the solutions we are proposing, and I cannot give you a precise numbers right now.
Thank you. Another question for all. Do you envisage to take advantage of next Green Deal calls to deepen your research endeavors and then better address the full-scale development and get an higher TRL as required by the market?
Well, I can start from Pitondur. You are referring to EU calls?
Sorry?
Are you referring to European calls, correct?
Yeah, yes.
Yeah. Well, I think that the upcoming Green New Deal effort from the Commission, which is expected to open in September and close in February, March, is a very good opportunity to bring at higher TRL those technologies that still need to be further studied and implemented. That's a good opportunity. It's an opportunity which aims at really implementing exploitable solutions. So that's something we are looking with interest. For some of them, of the solutions developed in the project, we foresee a shorter route to the market.
Is there someone else who would like to add something?
Yes, Daniela speaking for EENSULATE project. We are already discussing in the framework of the exploitation and the business model roadmaps that we are developing in our project, which are the possibility, and we already envisage the possibility of cooperating with some of the project partners. To develop and to further achieve a higher level in terms of TRL to put the products that we are developing into the market. We are considering the possibility of submit an additional proposal in the framework of the proposal funded by the European Commission with some of the partners of project to achieve this higher level in terms of production lines development and automation.
Yeah, and for the ENVISION project, we are looking for each technology separately, which we can develop further and we are open for discussing it to see in what kind of demonstration project at higher TRL we can further develop the technologies. In case of our panels, for instance, we can make them in every color at the moment, light colors, dark colors, but we're thinking towards the future to look at all kinds of different patterns, shapes, etc. So I think it's a lot of things to be done.
Okay, so there are no more questions, and we it's almost 12:30. So I would like to thank all our panelists and all the people who attended the webinar. Thank you for your presentations.
Thank you.
Thank you to all of you.